Hello everyone, I am Anirudh. I am here with Impana. We are currently pursuing MCA in Chanakya University. I am excited to present our research paper titled Advanced House Price Prediction Using Machine Learning and Ensemble Methods under the guidance of JB Simhasa. Our research paper mainly focuses on using different machine learning models for predicting accurate price for real estate stakeholders, especially in a dynamic market like India. We are comparing different models from simple linear regression to advanced ensemble methods like XGBoost, and stacked models. Our goal here is to find most boosting accuracy and enrich real estate decision making in India's complex markets. So first, we will be taking dataset from Kaggle.com. Here, the dataset that is we taken is consisting of 2,919 property records with 79 various distinct features split evenly into two sets, training set and test sets. The key features of these data are lot area, overall quality, great living area, garage cars, etc. The sales price of these properties range from 34,900 to $755,000, where the mean of these all prices comes to around $180,921. The pre-processing steps that is to be done for implementing our models on these dataset is handling missing data using medians or mode and removal of outliers by IQR. Standard and numerical features, one hot encoded categories and select the features, etc. In this research paper, we have took 5 different type of models and implemented them to check which is the most accurate and most right one that can be used. The models which we use are linear regression, random forest, decision tree, XGBoost, and stacked model. Simple linear regression is a simple rich regularization with alpha tuning for baseline linear modeling, whereas random forest is ensemble of trees with bagging to reduce overfitting and capture nonlinearity. Decision trees are single tree with tune max depth for interpretability but risk of overfitting. XGBoost is a gradient boosting model. It is to iteratively improve prediction accuracy, whereas stacked model is combination of more than one models to give a more leverage or diverse strength. These all models and the implementation pre-processing will be explained by my friend Impana.
Hi everyone, I'm Impana. First, we need to install some libraries like Pandas, NumPy, Scikit-learn, Matplotlib, Seaborn, and XJBoost. The first is to set up and data loading. First, we need to import the libraries which we have installed to make sure um, the code runs properly. After importing the libraries, we need to do the data loading. First, we need to load the datasets like train.csv and test.csv file. Later, we need to combine the train and test for consistent reprocessing. After data loading, we need to to go to the data pre-processing step. The paper emphasizes data cleaning, handling missing values, outlier detection, normalization, and feature engineering. First, we need to handle missing values, and the numeric column should be filled with the medium and categorical column should be filled with the mode. The outlier detections need to be used should be done using the IQR and applied. There are some key numeric features like plot frontage, lot area, overall qual, GR live area, garage cars. Next, we need to normalize numeric features like using the standard scalar and split back into the train and test. We need to split the X train and X test into two parts and then align clean training data. After doing all this process, we need to train test split for validation. Next step comes through model training and evaluation. The paper evaluates models using cross validation and mean square error. Below we implement linear regression, random forest and decision tree with parameter turning as described. First is the linear regression. Linear regression with cross validation with alpha regularization. First, here is the graphical representation of the linear regression between the alpha versus CV error using the ridge regression. Here you can see in the graph that it goes gradually down and increases slowly. This this linear regression trains the final model optimal alpha and plot the graph between the alpha versus CV errors. This is the mean square error of the linear regression. Next comes the random forest. Random forest with cross validation for n estimators. In this random forest plots the graph between the n estimators versus CV error and it optimizes the n estimators and trains the final model. As you can see in this graph, it is plotted between the cross validation error and the n estimators. This is the mean square error of the random forest can be seen here. Next comes the decision tree. Decision tree with cross validation for max depth. Here in decision tree, we max depth is calculated and like it plots the graph between the max depth versus CV error and optimal max depth. As you can see, this is the graphical representation of the decision tree between the cross-validation error and max depth. Here, the graph is getting fluctuated when it decreases and then increases, then decreases, increases like this. The mean square error of the decision tree can be seen here.
Now we'll be seeing how the data visualization is used. For here, we are using two different type of visualization method. One is a bar graph and one is a correlation graph. For bar graph, we are trying to find the normal distribution of house prices, how they varies, how density is this, or how you can say, which you can find what is the range where the prices, the proper number of properties are the highest. Here we can see the properties are highest between 100,000 to 200,000. Now for the correlation map, here we are taking top 5 features that are in the data and finding the correlation between them. Here the more warmer the color is, it is showing the more correlation they have with each other. For example, garage cars are highest correlation with overall quality, or overall quality is highest with grand living area. the cooler the color, the least the correlation there is. Now, to the previous research paper, which we took as reference, we have made some improvements. We have tried some improvements. Those are involving some newer type of models like gradient boosting type model and stacked models. For gradient boosting model, we are using XGBoost model. Here it's implementing, it is used here, and it is giving out the mean squared error as 377,355,872. For their learning rate is 0.1, max depth is 3, and an estimator is 150. Now for the stacked model, which is a combination of multiple models like linear regression, random forest, decision tree, and XGBoost using a meta learner, we are seeing there the stacked model is giving a mean squared error of 311,583,949, which is the least. Now, if we compare all these models with each other, we are finding that we are using a bar chart to show this comparison. Linear regression and stacked model are the one which are the having least mean squared error that denotes that these are the most accurate ones. Whereas decision tree has the highest rate of errors that you can find. XGBoost and random forest are in between. Here you can see those all together. Stack model has the lowest MSC, that is 311,583,949, which is the best accuracy through Ensemble learning. Linear regression, however, has 315,488,573. It is strong but still lacks nonlinear capture. XGBoost, which is in third, that is giving out 377,000, and random forest 494 million. Decision tree, however, has the highest, that is going for 1,066,305. Highest error due to overfitting. Overfitting is the reason it is there. Random forest is better than decision tree, but still below advanced assembles. This is a chart we seen. Now, let's discuss what we have found from these implementations. First, linear regression is a simple, interpretable, yet limited in handling non-linearity. Decision tree has higher interpretability, but prone to overfitting. Random forest and XGBoost can handle complex pattern better. XGBoost refines errors iteratively. Stack models combines diverse model strengths, demonstrating superior overall accuracy. What are the key factors that affects the model accuracy are? One is data quality and pre-processing. Outlier removal, normalization, encoding are very crucial for clean input. These are main factors that is a main factor that affects the model's accuracy. Second is feature selection, prioritizing high correlation features like overall quality, improved results. Third is hyperparameter tuning, optimizing parameters like alpha and n estimators enhance accuracy. Fourth one is external market factors. Local amenities and economic cycles influence prices. From this, what we conclude and is Assemble is the best has the best practices. Stack model offers highest accuracy in real estate price. Limitations were noted that are overfitting remains a challenge for simple models like decision trees. For future research, exploring deep learning, adaptive models, and real-time economic indicators can be major factors. Thank you.